See this problem. An AC circuit contains a resistor R, an inductor L, and a capacitance C connected in series across an alternator of constant voltage and a variable frequency. At resonant frequency, it is found that the inductive reactance, the capacitive reactance, and the resistance are equal, and the current in the circuit is I0. Find the current in the circuit at a frequency twice that of a resonant frequency. So, our motto is, if you observe this problem, there is no numerals, so we need to work out with the given variables, that's all. So from the problem we need to find out the current, that means I, assume that it is I or I1, when the frequency is twice that of the resonant frequency, and the frequency is twice that of the resonant frequency, that means when omega n is equal to 2 of omega naught, where omega naught is the resonant frequency before, that means when you are not increasing the current. Omega 1 is the resonant frequency after increasing the current. So I1 we need to find out. So as usual, we have a resistor, we have a capacitor, we have an inductor which are connected to the alternating source RCL, and this is V. So according to the problem, we have got a motto which is to find the current, and now we will investigate what are the quantities are given. So R is equal to XL and is equal to XC is the condition given at resonant frequency omega naught, and at that moment the current flowing in it is I naught at omega naught. And one more condition, that is omega 1 is equal to, that is a new resonant frequency which is equal to 2 omega naught. So these three are the conditions given in the problem. Now we will resolve everything. So from the problem, we already know that R is equal to XL, which is equal to XC. That means the current which is flowing in it, I naught, is equal to Vm by, or Im or V naught, whatever you can. The notation should be same. That means you have to represent the correct variables. We can write Im here and here Vm. You can write I naught and here also V naught, no problem. Concept is the main thing. So root of R square plus XC minus XL whole square. This is the formula for the current which is flowing through the circuit at a resonant condition. At resonant condition, XC is equal to XL, so that implies it become Vm by R. So I naught is equal to Vm by R. Now at one more condition also they have given, that is XC is equal to, we already know, 1 by omega naught C, which is equal to R, and XL is equal to omega naught L, which is equal to R. So these are the conditions or relations that we have got in first condition. Moving to the second condition for the current, like when the resonant frequency is doubled. So for that, at new frequency, assume that the current is I1. I1 is equal to Vm. Why I am writing Vm? The voltage source is not going to be changed. Root of R square, resistance also not changing, into XC dash minus XL dash whole square. So this is the expression for the current at a new condition. Now why? Because I am expressing Xc dash and XL dash, because due to frequency the inductive reactance and inductive capacitance will change, not the resistance, not the capacitance, and not the inductance. So if you take the a new reactive capacitance, Xc dash is equal to 1 by omega 1 C. This is the expression with the new resonant frequency. But we know that omega 1 is equal to 2 omega naught. So I am writing 2 omega naught C, which is equal to R by 2. Because this omega naught by C, 1 by omega naught C can be expressed as R. Similarly, XL dash is equal to omega 1 L. That is equal to 2 omega naught L, which is equal to 2R. I have got two expressions for XC dash and XL dash. So I am substituting this in the current expression. So I1 is equal to Vm by root of R square plus R by 2 minus 2R whole square. That is equal to Vm by root of R square plus, here also I'll get another R square into 1 by 2 minus 2 whole square. So with this I'm taking out this R square outside. So Vm by R square, if R square come out of the root, it will get it will move like a R into root of 1 plus, and this thing is 3 by 2 whole square. That is equal to Vm by R into root of 1 plus 9 by 4. That is equal to this Vm by R. We already got an expression this for this Vm by R. Look at this. I naught is equal to Vm by R. So I am writing I naught instead of Vm by R. So I naught divided by root of 13 by 4, or it can be simplified like 2 I naught by root 13. So if you increase the resonant frequency, the new current is 2 by root 13 times of I naught.